Okay. Today in session 4, I will be covering about sensors and communication protocols. So yeah, let's begin. Okay. So first thing, when you deal with electronics or robots, always you have input, processing, output. So sensors are the components which are responsible for entirety of the input part. Now, when it comes to sensors, okay, you can divide them into families based on what they sense, obviously. That would be like temperature, light, pressure, motion, or gas concentration, or anything else. Now, one another factor about sensors is they are classified based on how they transmit their data. Now, first one would be analog, and second is digital. Like in entirety of electronics, these are the two major branches, analog and digital. So, point one is what would be analog? Analog is intermediate value between 0 and 5 volts. So one example of such sensor would be potentiometer. Now I know that potentiometer is like a manual input, but for now let's assume that it is a sensor. There are some other sensors which are analog. Uh, okay, sure. So I guess those of you who are done with electronics workshop must be aware of light dependent resistor. So please raise your hands, those of you who know what LDR is. I'm pretty sure it was covered in JE. I'm not sure. Like, was it? Yeah. Okay. So a component like an LDR is an individual sensor which will tell you or give you an analog value. Hmm. I guess you still have to construct a Wheatstone bridge to use it as a sensor. Or how would we use it? Okay, you can make a resistance, you can keep this and a resistor in series, and then you can measure the voltage in the junction. Okay, yeah. Uh, so it will work as a sensor. Apart from that, we have many more sophisticated sensors, and these are usually sensor modules. Now, I can also have LDR, but I can have it as a sensor module. And as you can see here, okay, is the image visible properly? Yeah, okay. Now, this is also an LDR, but first point being there will be a cost difference. I'm pretty sure LDR should be like 5 rupees or so, but the entire module would cost like 35 rupees. There will be many differences. First point, usually if you buy a module, they usually communicate using protocols or they give you data and digital values. Like it's not that it is either 0 or 1. It's more that the output value itself is coded in binary and then transmitted to your sensor. Now, what is next slide? Oh, okay. I guess I'm done with the first slide. Sensors are anything which sense something and then transmit it to your microcontroller. So yeah, I was yapping about types of sensors, and in that we have digital and analog. Usually, analog sensors are like more rough and like they are easy to damage, I guess. Usually, for each and every sensor that you get, you also have a sensor module. Sensor modules have jumper pins, and jumper pins last longer. Like you can't bend them, but like LDR, I'm pretty sure if during electronics workshop you handled those, you should have noticed that the anode and cathode, or okay, the metal wire is easy to bend. What do we call that? Okay, whatever. The metal part is easy to bend, so it's easier to damage. Its life is shorter, and second thing is that you can tune your modules. That's a very good advantage. As you can see, there is a potentiometer over here. And what the potentiometer does is it allows you to fine tune your LDR in such a way that one segment of the input value is like amplified. So you can distinguish between there being a light source and there not being a light source. Like there will be a sudden jump in the binary values which you will see. Okay. That's all for sensors. Is it recording? Yeah, okay, it is. Yeah. So we'll okay, one second. So usually there are ton of sensors. There are like many sensors, like dozens or like hundreds, and that should be many. I'm not sure how many, but yeah. In general, there are like a fixed set of sensors that you might come across in robotics, and there would be ultrasonic sensor, humidity sensor, and motion detection sensor, LDR, microphone, and anything else, gas sensor. Oh, okay. And one of the most important one would be accelerometer. But yeah, there are many types of sensors, but I will be covering only some relevant sensors in today's class. Yeah. So first we'll be starting with DHT11 slash DHT12. These are two different sensors. DHT11 is like bit older version. DHT22 is the newer version of DHT11. Uh, More confusing than Samsung or Apple's naming series, but yeah. So what exactly is DHT11 slash DHT22? It's a temperature and humidity sensor, and it comes directly, like you can have a bare metal sensor like this, or you will have what do you say, sensor module. Like the picture which I attached here is a sensor module, and you also get a library to program with. Hmm. Yeah, okay, sure. So it's full working. Oh yeah, okay, it is full working. So these are a bunch of sensors I have on me right now. Like I don't have more sensors, and like some of them are in hostel and rest of them like they're in lab. So here I used a DHT11 sensor. I hope. Okay, it's the screen clear. Is it fine? Okay. So the small sensor that you see over here, it is DHT11. It's blue in color. And here I have interfaced it with an ESP32. So basically, it will just read the temperature and humidity and give it back to me. I'll show you the code too. So basically, for majority of the sensors, which are like a bit complicated, you get a individual library for it. So here, as you can see, I have a library called dht.h. And after that, I declare a pin. And using that library, I declare my object and I basically read the value. Now, right now, the code itself is not necessary. Like usually, I don't memorize all functions from a given code. If I'm working with a given code, I'll go to their library or I'll go to a website. I'll learn about the basic uh, functions and then I'll utilize it. So right now, there's no point in you like understanding the code completely, but I'm just showing how the code looks. And here I check whether one of the values is corrupted or not. And if it is corrupted, I'll serial.print reading failed. If not, I'm printing my humidity and temperature right now. So right now, like if you can see the serial monitor, you can observe that my room's humidity right now is at 72% and the temperature is around 26. So yeah, that is your DHT11 sensor. And usually you can just go over to Google and like search DHT11 ports or so. And I'm not sure if it's there on Walkview or not, but if you want to mess around, you can do that. Yeah. So DHT11 should be around 100 or so, and DHT22 is like 200 rupees. It is more accurate, it is newer, and yeah, I don't have more words to describe it. It's like iPhone 11 and iPhone 16. I yeah, I don't have anything else to explain yet. But yeah, why is it that important? If you are building web server or like starting off with some very basic IoT projects, usually people build a weather station. And if you're building a very basic weather station, you start with DHT11 and then you use your ESP32 to host a web server on your internet, and you basically publish that data on your net or Bluetooth. But yeah, next one is ultrasonic distance sensors. So, okay, yeah. So raise your hands if you have ever heard about this ultrasonic distance sensor. Okay, tells me like, okay, 20 of you. That's cool. 25. Interesting. Now, if I remember correctly, in assignment two, the bonus question which I asked you guys to do, it was a left wall follower robot. Am I right? Was that the bonus question? Hello, please message or talk. No? Did I ever ask you guys to make a left wall follower robot? First time hearing about it. Yes, okay. Neelkant, you say yes. Can you tell me which assignment, which question? Like, I do remember asking you to make a left wall follower. Okay, sure, never trust that guy. Okay, bro. Oh, okay. So very interesting. I guess that would be your assignment for left wall follower robot. But basically, when you enter robotics and you're building your first mini project, it's always one of these two, left wall follower or line follower. Now, left wall follower robot, it's based on ultrasonic distance sensor. So yeah, I guess I'll show the slide. So what is ultrasonic distance sensor? It is a distance sensor which uses ultrasonic waves. Yeah, crazy. Yeah, okay. So uh so basically you have an ultrasonic sound wave, which ultrasonic, infrasonic. I guess it's about 20,000 hertz. I'm not sure, but basically that frequency wave goes forward. If there's any object, that wave is reflected back. And I like it's been a long time since I've had this sensor. I've been working around with it, but I still don't know why are there two meshes or why it looks so weird. But basically, the sound wave goes and it's received back, and your sensor is able to figure that out. So basically, you measure the time difference between your pulse being generated and it being captured, and you multiply that time with the velocity of sound, and then you divide it by two. Okay, sure. Yeah. Okay, I'll come to that point, but yeah, ultrasonic distance sensor. Point one, yeah, obviously you know the distance. I guess. Hmm, okay, I guess it's not that accurate about 30 centimeters. I Yeah, it's not accurate about 30 centimeters, but yeah, it uses sound and it can only detect objects. Now, do I have any other point? So basically, when you put three of these sensors at 90 degrees at the front of your car, or like at the front of your two-wheel drive chassis, you get a robot which can basically give me one. Yeah, which can basically detect walls on three of the faces. So that's what we call a maze solver robot. If not, I guess. Anubhav or Ashwin sent some videos in your group. So do look at that. That was a line follower robot. Okay, never mind. We'll come back to it later. Oh, oh yeah. Okay, this one. So basically, you have your two-wheel drive robot, or for now, just assume it's a remote-controlled car, and you put three of these at 90 degrees. One would be to the right, other one would be to the left, and other one would be to the front. And basically, that would allow you to travel through mazes. Like you can, yeah, you can navigate safely through a maze. That is a maze solver robot. Now, let me just search for my code. Hmm, not good. Okay, give me 2 minutes. I'll try to show you the sensor working. Oh, okay. Okay, so that went fine. Oh, okay. Perfect. So, okay, I'm sorry, my cable is too short, so I guess mm, yeah, okay. So this is my ultrasonic distance sensor right here, and this is my Arduino Uno R3, the one which I got from iBot Club. The advantage of being a coordinator. And okay, why not? So basically, I'll place an object at some distance like this, and what happens is, so I don't know which one is emitter and which one is receiver, but one of these two tubes, they emit sound at like 20 kilohertz. That sound will go forward, it will hit this object and it will come back. And based on that, we calculate the time taken. So don't pay much attention to the code. Like obviously during your assignment you need to, but you can refer to some external resource. I will send the codes. If you want, I'll explain it later in some short video. Basically, I have a echo pin and a trigger pin. When I set off the trigger pin, the sound is like the sensor is triggered and a sound wave is produced. And then the echo pin is a receiver pin. And here I note down the time duration taken for the pulse to be received back again. So then I multiply it with 0.343 velocity of sound, and then okay, 0.343 by 10, which is velocity of sound in centimeters or something. Duration is in microseconds. So use your JE brain and like understand why that 10 power came. But yeah, so basically, if the pulse is not received back, I'm just declaring that no object detected. If not, I print the distance. So, okay, can I have both of them? Oh, okay. So now, like when I slowly move my object away, you can see that the distance increases 8, 9, 10, 11. Um, like it's no longer in the frame. So, yeah. As you can see, there's a trend. Just now I moved the object far away and like 6, 11, 14, and now what? 377. Okay, I will measure the diameter of my room afterwards. It says 377, but I don't believe this sensor. But okay, so that much for the ultrasonic distance sensor. This is one of the three horsemen, I guess. Yeah. What would be the third horseman? Because DHT11 is very chopped. It's not. Hmm, I just randomly picked it. But okay. Just assume ultrasonic distance sensor and IR sensors to be very important, because usually when people start off with projects, it's either line follower or it's maze solver, and one works on IR sensors, the other works on ultrasonic distance sensors. Now, unfortunately, I don't have my IR sensor here, so I don't have a demo with me. But if any of you is interested on the code, but I have it on my GitHub. Like, I'm pretty sure during your DC app, I did share it. If not, I'll share it again. So, what is a IR sensor? Now, IR sensor works on the basis of infrared radiation, that is light. And second thing, objects don't reflect light necessarily. Like black objects will absorb light, and white objects will repel or reflect the light back. So basically, what does the IR sensor do? It can differentiate between black and white color. It's like digital racism or something, but yeah. So basically, yeah, infrared radiation, some object, it will. So you can see there are two LEDs. The transparent one is the IR LED. It is a light emitting diode which emits light in the frequency range of infrared rays. And this black one is a infrared rays receiver or detector. Uh, how does it work? I think so. During JEE, you should have learned this. Basically, there's a small segment where if a light ray goes and hits the atom, electron can move forward or something like that. I don't remember it well right now. But basically, whenever there's a black color object, it will absorb all the IR rays. And when there is a not black object or any object which reflects IR rays, your receiver will say that, oh, I can sense something, and it will tell you that there is a difference in the color of object. It's not necessarily that it will tell you which object it is, but basically it will tell you that, oh, and now I am on a different surface maybe. So yeah, this is not necessarily a solving robot. Okay. So this is a line follower robot, and in this image, it's too small. No. Oh, okay, fine. So basically in this image, there are like three IR sensors at the front of the chassis. And basically the middle IR sensor will have a low reading value, and the extreme IR sensors will have a high reading value. So basically you can say that there is a object which is, or there is a black colored tape which passes through the middle IR sensor. Does that make sense? If you understood, please raise your hand. Hmm. 70. What? Can you repeat? What do you want me to repeat, bro? Oh, raising your hand. If you understood what I taught, please raise your hand. If you want me to repeat IR sensors, please go through the PPT and the screen recording afterwards. Okay, it tells me 22 people have raised their hands and there are 26 DCs here. Last line. What was the last line? How do you use IR sensor in Fallen? So your IR sensor for now basically is racist. It will tell you is it above a black object or a white object. Now your middle IR sensor will tell I am above black object. Your left and right IR sensor will say I am above white object. So you move forward. Now if your tape starts moving to the right, your middle IR sensor will be like I am above a white object, and your right IR sensor will be like I am above a black object. So you turn right. Does that make sense? Okay, cool. So how many people raised their hands? Hmm. Surya Nilkant, was I not clear? Hello, Nilkant, Trivikram, Sikdar, and Surya. Okay, Parthiv, are you just like camping? Hmm. Okay, Nilkant, Trivikram, Sikdar. I'll remember you, bro. Hello. So, did you hear my question? I just went to get food. My bad. Okay, it's fine. I hope you listened to the part earlier. So, I was asking, was IR sensor clear? If you didn't hear that, I'll send the video. Please do go through it. IR sensors are important. So, oh, okay. So, during our iBots event, we use this thing. This is a IR sensor array, and basically it has 7 IR sensors. So, it basically gives you more accuracy or control over. Okay, it tells you more precisely where the black tape is. So, you can control your line follower robot a bit more precisely. If everything goes as per plan, we'll be handing out these sensors to you to play around. Everyone except Anubhav, Shaijesh, and Ashwin because they already use this. But yeah, so this is the IR sensor which I have. Oh, now that I think about it, I did have this IR sensor. I could have interfaced it. So yeah, I will send a code, I guess, regarding this IR sensor. So yeah, take light on that. We'll move back to other stuff. Okay. That's all for the IR sensors. So okay, see, point one, if you want to learn more about line following robots, there are like ton of YouTube videos which explain that in a very good detailed manner. And they do teach you how to make your own PCBs. They do teach you like how to make very good algorithms and so on, a maze and all. But yeah, okay. That's all for IR sensors. So next thing, I know this is not related to the class right now. I just wanted you to have a thought experiment kind of thing. So basically, there is this thing called 7 segment display. It shadow people. What? Okay, I didn't get you, but hmm. So basically, there exists something called YT people, YouTube. Bro, there are YouTubers, bro. There are professional people. Oh, okay. Who can show how to make your PCBs or something you said just now. Bro, just search it on YouTube. I guess you people have been living under a rock because before 12th, you don't know what to search on YouTube. But basically, if you have any doubt, go to YouTube. There are amazing teachers out there, teachers who are way more qualified than I am, and they will teach you whatever you want. You search, if you want to make a PCB, search how to make a PCB. They will tell you. No, 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 no. Never mind. It was not a specific person. Yeah, okay. Uh, okay. So coming back to a thought experiment, there is something called a 7 segment display. It is present inside your lift, not lift, but like your lift ka button wala panel. So this is redundant. Display. So okay, I guess I had a very decent picture. Oh yeah. So this is how it looks like. Basically, what happens is there are 8 LEDs behind each of this alphabet here. So there is one LED corresponding to A, B, C, D, E, F, G. Now, okay, I guess I'll put assignment or oh, okay, today's attendance in chat box. Basically, write your roll number using this format. If your roll number is 6, 7 like me, you put A, C, D, E, G, F, and then 7, which would be A, B, C. Now, this is your attendance put off. I'll give you 2 minutes exactly. iBot. Uh, okay, where? Oh, okay, cool, cool. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now, I think 10 more people are left. I will, okay, 8 more, 7, 6 more. Yo, Vishwa, I guess you joined just now. So for today's attendance, you have to put your roll number in a format which I'm showing on my screen right now. So basically, if your roll number is 67 like me, you put A, G, C, D, E, F space A, B, C. That would make your numbers. So yeah, if you want attendance, you type it. If not, I'll give you 1 minute, bro. Put it. Oh, 141. That's nice. BC, FBGC, BC. Yeah. FBG, FGBC, FGBC, BC. Hmm. दिल्ली से हूँ. Yeah, okay. Now I guess 3 people are left. I'll catch you later, bro. These 3 people. Okay. Now we were dying to control 8 LEDs or 7 LEDs. Now, what do you think we do when it comes to LEDs looking like this? Now, this is 64 LEDs in a single unit, 8 LEDs like this, and 8 LEDs like this. Now, if we follow the same, chill, bro. I'll come there. Not a shift register, not right now. I'll explain. Now, oh, were you the guy who had a shift register and made some project with it? Thought so, thought so. Don't worry, bro. Then, okay, I will come to that point. Shift register is actually a very good answer, but not exactly. So, yeah. So, this is 64 LEDs. Now, we can't have 64 pins. Now, this is 256 LEDs, and we can't have 256 pins. So, what are these modules? Like, what are these things which are there on my screen right now? It is something called LED matrix. So the first module which I showed you was 8 by 8 LED matrix. There are 64 LEDs, and it okay, we made this unit such that we print these columns one by one. So if the text on my screen makes sense, an 8 by 8 LED matrix module is a display device made up of 64 LEDs arranged in 8 rows and 8 columns, allowing patterns, blah blah blah. Okay. Okay, the last line, the matrix is typically driven using row and column scanning to reduce the number of control lines required. Now, if we followed the old procedure, we would require 64 pins. But these people are telling, let's control it line by line or row by row and column by column. So 16 pins are enough. So I had a very good illustration somewhere. Yeah, this is what we do. We have 8 cathodes, 8 anodes, and we individually turn them on and off quickly, I guess. I'm not sure actually. So now this thing might sound a bit redundant. Like if you have 8 pins or 16 pins over here, what do you do when you're dealing with displays like this, which has uh, 256 pins? Now, the thing is, there are all these, like the same module is used in both of these units, but the thing is, it is a bit stupid to use like 16, 30 to 64 pins of control. So because of that, we developed some clever ways to control peripherals, I guess. We, oh yeah, rather than using these pins themselves, we have something which is some pins which are for communication purposes. And these pins will communicate all the data or receive all the data as to what should be the state of my 256 LEDs. And they will, using these 16 pins on the back, they will control all 256 pins. Now, initially, I had my dot matrix display on this guy. I removed it, like it is removable. I will put it back after class. So basically, we have this IC. This IC will receive the data from these pins and will control the display using these 16 control pins. So that is how like communication protocol is, or that's why we made communication protocols. So yeah, coming to second topic of our class, communication protocols. So first of all, I know I taught you Wi-Fi and Bluetooth, like I introduced you to them, but for now, let's talk about serial communication. Serial communication is a method of data transfer in which information is sent one bit at a time, one after another. Now, one of you mentioned a shift register. So that one particular guy, we use shift register so that we transmit the data one by one. We use the shift registers in the transmission and receiving part. It is used, but it's not the entire thing. For rest of you, we send data offline one by one using wires. Yeah. Okay. So this approach reduces the number of required wires and makes communication simpler and makes reliable, or is more reliable over longer distances compared to parallel communication. What is parallel communication? We the 7-segment display wala thing. You use 8 pins to communicate status of 8 LEDs, but here you rather use one single wire to tell you the state of all LEDs. If like if some of you have a doubt, then why are there 5 pins over here? There are different protocols which require extra pins, and there's also VCC and ground to power the entire thing. So that will account for it. So what is serial communication? Serial communication is offline transmission of data using minimal number of wires, where the data is sent one by one. Now, the programming of Arduino or the programming of what do you say, ESP32s, they use some form of serial communication, I guess. I think so. They use SPI. I'm not sure. Oh, data field. Why? Hmm. Okay, so that's for serial communication. Now there are three horsemen of serial communication: UART, I2C protocol, and SPI protocol. These are three very famous protocols. These are the basic protocols. Tomorrow, if you join a comp team, you won't be using any of these because all three are stupid. Like all three have some issues. If you join a comp team, you will be using something called a protocol, or something which starts with CAN. Mm, you can search that on Google. But UART, I2C, and SPI together lay the foundation to all the cheap protocols. Our comp teams have high budgets and they rely on speed, so those guys use CAN. But yeah, so first of all, UART. UART stands for Universal Asynchronous Receiver Transmitter. Now, universal, you can scrap that word. Asynchronous, it just means that there is no clock signal. Receiver transmitter, we have a receiver and a transmitter. So the name means no clock, receiver and transmitter. So yeah, basically this is what we see while programming an Arduino. Now I guess if you used or you should have used Tinkercad for your assignment too. In there, the pin 0 and 1 of Arduino is mentioned as RX and TX. So we use UART to program an Arduino if I'm right, or I might be wrong, but yeah. Basically, what happens is in UART, you have two modules and only two modules. These two modules talk to each other simultaneously. Now, because there is no clock, you have to inform both the modules at what frequency you're talking. So the second module will start picking up data at the same frequency, and like no data is lost. So how would that look like? This is how it should look like. So your first transmitter will be like, oh, I'm starting, and it will send 7 bits or 8 bits of data, and it will stop. And because your receiver is also receiving or trying to read the data at the same frequency, it will at least read every bit once. Or sorry, it will perfectly read every bit once. As you can see, if I'm reading here, and then I'll wait for some time, and because I know frequency, I'll exactly read at another point. So there might be a skew, like I might be reading just the beginning of this bit, or just the end of this bit, or some arbitrary intermediate value, but I'm reading each and every bit perfectly because I know at what frequency I'm transmitting the data. So that is what UART is. Now, a bit of terminology: simplex, duplex, or complex. What? Hmm. Yeah, okay, simplex and duplex. So we have something called duplex. Duplex just means that a two-way road. Like we have a two-way communication. So in UART, usually your first transmission goes to the second guy's receiver, and the second guy's transmission goes to the first guy's receiver. So the entire thing is a duplex form of communication. We have a two-way road, or we have a two-lane highway where like data can go from one side to the other, and the other side to the, what am I saying? Okay, you have data flow from first unit to second unit and second unit to first unit. Now we have something called half duplex. Half duplex is a single lane highway where traffic needs to go in both directions. So what happens is first one direction data flow happens and then the other direction data flow happens. That is half duplex. And then we have simplex. Simplex is a one-way road. You have a master and a slave, and master will tell slave all the information, but master doesn't know what happened to the slave afterwards. Bro died or bro received the data. He doesn't know. So yeah, UART is duplex, like I explained. We have a two-lane highway where traffic is moving in both directions simultaneously. And there is no clock. So there is the word asynchronous. Asynchronous means that there is no clock signal. It's just that both units know at what frequency we are transmitting data. So I will give you around 2-3 minutes. If you have any doubts, put it in the chat box. And if not, put raise your hands. Um, doubt if there is no clock, how is data read at a particular interval? So we inform both the transmitter and the receiver at what frequency I'm transmitting the data at. So what happens is my first transmitter is suppose transmitting data at 10 hertz. I will send 10 bits at in a single second. Now my receiver knows that I sent 10 bits in a second. So the receiver will read at 10 equally placed intervals in a second. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 readings which occur at equal distance in that 1 second. So what happens is there will be a little bit of skew. Like I will not perfectly read the center part of the data always. I will be reading sometimes the edges, not perfect edges, but just after the bit change or just before the bit will change. I will read it. And it just so happens that in 1 second, my transmitter will transmit 10 bits, which are equally placed. Like 0.1 second will be start, 0.1 second will be data 1, data 0, 0.1 second will be data 1. And my receiver is also reading at 10 hertz. So it will read at least once every 0.1 second. So it will read this start bit at some point of time. Does that make sense? Kinda. Yeah, yeah, it's fine because I'm teaching using slides. It won't be perfect. Afterwards, I recommend that you guys check out some video simulations kind of things. And see, I'll tell you one thing directly. I learned UART, I2C, and SPI in my third semester in a core course. I knew that these three things existed, but entirety of my first year during my DC tenure, I don't know what jack shit it was. Like I didn't know the difference between UART, I2C, and SPI. I know now because today morning I read it again, and also I had a 10 credit course on. I had a 10 credit course which covered UART, I2C, and SPI. So if you don't understand, it's fine. It's just a foundation. Afterwards, if you're a signal or communication engineer, you will be knowing it in a bit more detail. Now, next we'll come to I2C protocol. I know, like, I guess I'll take 15 minutes after 10:30. Please bear with me for today. So yeah, I2C protocol. It stands for no, sorry, inter-integrated circuit. Stupid name. I agree it's a stupid name, but we have two signals. First one is SDA, second one is SCL. SDA is the data line, SCL is the clock line. So basically, we have one master and we have a ton of slaves which are connected to SDA and SCL. And what happens is that your master will generate a address, or okay, I'll read through the slide once. I2C stands for inter-integrated circuit, and it is a serial communication protocol used to connect multiple electronic devices using only two communication lines. One line is used for data transfer and the other is used for a clock signal, allowing the devices to stay synchronized. Each device on the bus has a unique address which enables multiple sensors and peripherals to share the same communication lines. Now, a ton of information, reducing everything. We have a single master. We have a ton of slaves where everyone is connected to a common clock signal and a common data signal. So what happens is, initially, your master will be like, oh, okay, see, clock is constant. It will be vibrating at some frequency, but suddenly your master will go, okay, I'm starting my communication. And your master will spout a bunch of address and it will tell, I want to talk to you or I want you to talk to me. It will declare that using the read or write bit. And then the person having this address, he will tell that, okay, bro, I received your acknowledgement. I understand that you're talking to me. It is my address that you transmitted right now. And then afterwards, if the master was like, bro, send me some data, that one peripheral will send a bunch of data. If not, if the master was like, oh, I'm writing a bunch of data to you, receive it, the peripheral will receive that data and it will be like, okay, bro, I'm done. It will send a second acknowledgement bit and your master will be like, oh, okay, I'm done. So this is I2C. I2C, basically a single master, multiple slaves. It is synchronous because there exists a clock signal, and it is a half duplex because there's a single data line. At a given point of time, either the master is writing to the slave or the slave is writing to the master. We have a single lane highway and the traffic can move only in one direction at a given time. Master will write to the slave or the slave will write to the master. So that's why we call it half duplex. Uh, both times slave sends acknowledgement. I don't know, bro. I know that the first acknowledgement is always sent by the slave. The second acknowledgement, if my common sense is common sensing, if the data is being returned to the slave should give acknowledgement. If the data is being received by the master should give acknowledgement. This is what my common sense says, but these things are not so commonsensical. Like some guy was high while writing the code, so I don't know. That guy was like, "Oh, never mind. Both acknowledgements is given by a third party." So my common sense says that clock does nothing, bro. Clock does nothing. It's just that because we have a clock then it is more accurate or there is less loss. See, asynchronous and synchronous, the only difference is there is a clock and there is not a clock. And why is there a clock? I don't know. I don't know, to be honest. Like, because if there is a clock signal, there will be a certain amount of time which takes the clock signal to arrive. Mm, okay, see, there exists a concept called hazards. Now, for now, ignore the entirety of that topic. Those of you who are in ALEC, welcome to semester 2 at IIT Madras. You have a course called Digital Systems EE 2002. There you will learn about hazards and you will not understand anything. But all the best for others, other people here. The clock makes sure that the data is not going through some form of transmission, and the data is crazy, bro. IBME people, Ambe people also got Texas. Crazy, crazy. So yeah. So basically, the clock signal ensures that the data is not undergoing a transmission while we read it. So yeah, that's it. There exists a clock signal, so it will make sure that the data is read when the data is stable, rather than it undergoing a transmission. Like as you can see, the data can move at intermediate values. So if you don't have a clock, you might end up reading that intermediate value, and you will think that, wait a second, there is a 0.5 in between. What will I do with a 0.5? There, what? And yeah, you don't want that communication between your communication protocol. That will ensure whenever the value is being read, it's either a 0 or it's either 1. Was that clear? If you have any doubts, put up the doubts. If not, like raise your hand. And if you don't have a doubt, but you didn't understand it either, you can just not react. Like super explanation. Yeah, okay, sure, bro. You can not do either. So basically, the clock tells when to read the value. Yes, perfect. Yes, yes, yes. So you can avoid the transmission. Not sure. Yeah, I'm not sure. I'm not sure. Like today in the morning when I was reading, ChatGPT told me at 11 a.m. that having a clock signal allows you to perform faster transmission protocols. But the same ChatGPT told me at 4 p.m. that I2C is slower than UART. So I'm not sure about other facts. So yeah, light on that. Okay, I'll give you one more minute, I guess. If you have any doubts, put up the doubt. By the way, some of you participated in uh, Maker Fest, and I saw that you guys have some very great codes. So please do share them in the group. If there are any interested people, they'll go through your Walkwe projects. These guys had some very good projects in Walkwe, not something which is very crazy. You should be able to understand it easily. So please do go through it once. Or like if you're interested, please do go through it. So yeah. That's it for I2C. If you don't understand Max, you won't come across I2C until you join some specific team which uses I2C in their cheaper modules. But yeah, for now you're a DC, so light. What is SPI? Now, SPI wants the advantages of I2C. It wants to talk to multiple slaves at the same time, but also it wants a two-lane highway like your UART. So SPI is what your laptop is kind of based on. Your keyboard, your mouse, your touchscreen monitor, your Wi-Fi receiver, your Bluetooth receiver, everything in your laptop usually works using SPI. Like during my microprocessor theory, I did come across some very modern but bare metal computers. And in those computers, the peripherals were communicating using SPI. So I'm pretty sure that SPI is like the boss of everything. It's like the final thing which majority of the people use, except for some very niche, what do you say, upgrades. But yeah, what is SPI? SPI stands for Serial Peripheral Interface. It is a high-speed serial communication protocol, and it uses separate lines for data input, data output, clock signal, and device selection. So basically, this guy is like, oh, bro, we need to do everything very quickly. So this guy will even not put a spout a address like your I2C. I2 is like, oh, this is the address which I want to talk to. But this guy, he's a giga chad. He will directly go to the module and he'll put some signal called chip select. It's a single bit value. If the chip select is one, that chip is selected and he's talking to that. So SPI is like a giga chat who doesn't bother using addresses. He uses chip select. And then it's also a two-lane highway. It's like UART. Bro wants to talk to the module and also receive data from the module simultaneously. So you have a data input line and you have a data output line. And then you have a clock signal so that bro also gets the advantage of I2C that you're never reading the intermediate value in the transmission of data or in the transition of data. My bad, transition. Hey Roy, did you send your maker first codes in group? No. Okay. Send it after today's class. Okay. Even the other guy from IBM is Sanmitra or someone also participated in maker first. Others also have done. Yeah, please send your maker first codes. I'm not going to judge it, bro. It's just that you people can share all the codes that you have. Oh, that's great. That's good, Avirat. So yeah. So SPI. Oh, okay. Nice. Neelkant, congratulations, bro. Nice. Yeah. But so basically, SPI. Well deserved, bro. Very well deserved, bro. Yeah. Okay. SPI, GigaChat, end boss. Bro has a chip select, so it doesn't require a full address line, and it has a two-lane highway, so data will go to the peripheral and come back from the peripheral at the same time. What is a peripheral? Peripheral is your keyboard, mouse, or any other module. Anything which you're trying to talk to, for now, it's a peripheral. Yeah, that's it. So yeah. So this is how your communication in SPI would look like. There will be a chip select line, which I cropped out from the image because the image was too long and my slide was too short. So there is a chip select line below. The SPI protocol will first select the chip or a peripheral, and then it will send a bunch of clock signals. It will send a bunch of data and it will receive a bunch of data. No, here you can see that there is no simultaneous communication because we are looking at a very low level, or like your Arduino is too weak, your ESP32 is too weak, but your laptops which has like Intel 13 gen or Apple M2 gen or M2 architecture, I think so those things have a simultaneous communication. I think so. I didn't do a higher level course in communication protocols, but yeah, that is what SPI is. So comparing these three, your UART is full duplex. There's a two-lane highway. Your I2C is a single lane road which wants to have traffic from both sides, so it is called half duplex. And again, your SPI is a two-lane highway, so it's full duplex. It's not a fake duplex like I2C. And asynchronous UART doesn't have a clock. I2C and SPI have a clock. Rest all you can ignore as of now. I'll send the PPT if you want, you can go through it, but it's not that meaningful. Like it says, there is no addressing in UART, there is addressing in I2C, and there's a chip select line in SPI. Like all of the rest of the information is a bit redundant. You can go through it later. Oh, okay. So that's it for that part. So if you have any doubts regarding today's class, please put it. Also, I guess I'll take a second round of attendance, and I also have some other stuff to show. So yeah, so basically, uh, here I have a ESP32. I have a DHT11 sensor, which is a humidity and uh, temperature sensor, and then I have an OLED display, which is 128 by 64 pixels. Now, what is 128 by 64 pixels? It's basically something which is like this, but way smaller. I tried to upload a code, it didn't work. So for now, if you have any doubts, put it. I'll try to upload the code and show it to you. If not, we'll pack and I'll send a video later. Hmm. Okay, I see that none of you have any doubts for now. So I guess I'll proceed with the attendance, or no, stay back for 5 minutes. If this fails, then you can leave. Or I'll take attendance and then you leave. As of your assignment, I guess I didn't send you an assignment for it, but I did mention one question where I was like, go through something. What was that? What was your assignment for? I did remember telling you something. PID? What is PID? Yeah, PID. Yeah, PID. Wi-Fi. Uh, I, I guess I told you to check out Wi-Fi and never gave you a assignment on Wi-Fi. Too sad. Okay, so wait, I'll check out your message. We had assignment on PID. No, Rafi. I just mentioned it in group, but I never sent out the assignment. I'll send out the assignment now. In PID, I guess I want you guys to check out the lecture series actually. Yeah, never mind. Just check out the lecture series. You told to see those unstable pins. Can you explain me a bit more what unstable pins? I frankly forgot. It was sensor control and okay, I guess I disconnected and reconnected this and now it doesn't work. I guess when I get this thing to work again, I'll send a screen recording of that. Yeah, it's not working now. So input pins not connected to anything without pulled on. Oh, yeah. Okay. Uh, but let it be. I just okay. That's nice. My sensor is working now. What? Okay. What? Okay, alternate readings are working. Okay, bro is playing with me at this point. Inside. Okay, wait for 3 more minutes, I guess. So, as of your this week's assignment, um, okay, I guess I'll give you a question on OLED display and walkway. Or I guess you guys should set up walkway on your VS Code. So I guess I'll compile it. I'll compile all the tasks and share it with you later. Did you set it up, bro? Oh no, I didn't get enough time. Actually, Shastra round once happened in the last 4 days for LXFest, so I was busy the last 4 days with those works. I will check it out now because like my other PR work has concluded for now. I will spend some time on R&D. I'll also try to replicate the game which you made, I guess. I did want to make some OLED display games for some for that pure. Yeah, Rafi, I guess it's a good opportunity to check out games which are based on OLED displays, I guess. Most likely it won't get approved, but it would be a great experience. But yeah. So so my project worked out now. So consider it done. Yeah. I guess if you are working on something right now, don't waste your time on this. But yeah, basically, I have my OLED display. Now, your generic marketplace OLED displays have like 7 to 8 pins, but this GigaChad OLED display purely works on I2C protocol. So you only require 4 pins. Now, using this DHT11 sensor, I'm reading the humidity and temperature of the room right now, and and yeah, and as you can see, my serial monitor receives the temperature and humidity here. And I went through the, what do you say, a website which told me how to use an OLED display yesterday and today. So I had this lying around, but I never actually used it. So I finally learned how to use OLED displays yesterday. And basically, I'm printing my temperature and humidity on this right now. Unfortunately, I zoomed in on my camera, so the quality is very bad. But basically, I have two lines. The first line says temperature and gives a temperature value. Oh, sorry, humidity, and says 76% humidity. And okay, I guess that was Duolingo. And my second line says temperature, and it's around 26 degrees Celsius. And OLED displays are actually pretty cool. For 350 rupees, you can get a mini monitor which can do a lot of funny stuff. Like, okay, I'll also take your attendance shortly. Any doubts or okay, I see that there are no doubts. Sorry for extending the class. I know that you people wanted a class less than 1 hour, but I will finish it shortly. I just wanted to show you some practical stuff because last year my coordinator who taught me didn't show me a lot of circuits. So I thought electronics is all about simulations right now. So I didn't have much interest. But I promise you one thing, in February, I will try to get you a bunch of components. I will split you into two-member teams or single player teams, and I will give you components. I'll let you uh, make your hands dirty or something. But yeah, I'll let you work around with some components. You won't be getting a lot of costly components. At max, you'll be getting an Arduino Uno RT1 sensor and a buzzer or some output servo like thing. I will try to get some OLED displays if the club allows me. But yeah, COM6 failed uploading. Why COM6 issue, bro? It's not used Canada. Oh, okay. Hmm. This should work. NCG, yeah, bro. Bro, elegant NCG, it's only one guy out of 156. That guy also has like a 10 CG in SEM 1 and SEM 2. He fucked up SEM 3. Oh, there is one guy got 10 CG in SEM 2 and SEM 3. Fucked up SEM 1. It's a bit sad. But yeah, 10 CG is not easy, bro. And especially if you have a bunch of PORs, 9 plus CG is hard. You will understand the bitter truth. Right now, you have SEM1 courses, so you think high CG is like very easy. Wait for your core courses and core RG. It will be very interesting. Ah, nice. So advantage of OLED display, you can do some pretty cool shit easily. So right now I took iBot Club's logo and I used a software which which converts that logo into pixels, and I uploaded that pixel data into my code, and I got this. Unfortunately, my cable is not long enough that I can flip it, I guess. Yeah, I can't flip it. It will go out of camera. But yeah, you can do some very good stuff with this OLED displays. It gives you great flexibility. Apart from that, yeah, I don't have flip the camera. Can I? Nah, bro. I write the code in negative iteration for columns. Unfortunately, I'm using a function which is built into the library. So I usually give it the logo itself rather than printing the logo line by line. So I can't do it iteratively or reverse the iteration. I can technically invert the data right here, but it's going to take some time. And I guess you can take up that as a task for now, like so. Yeah, I'll take attendance and let you guys go. So, hmm, Adya, Abhirat, Ajay, Bhavishya, Divyansh, uh, Divyanshu, Diansh, Gautam. Yep. Jason, Manasvi, Rafi, Neelkant. Yeah, okay. Nikhil, Nisha, Vaidish, Pragadish. Okay. Uh, Pranav, Riyansh, Roy, Pranav. Okay. Sanjana, Sanmitra, Sarveshwar, Shreyasi. Okay. Surya, Toshita, Vakhen, Vedant. Did Surya put present? Nope. Or did he? Oh, yeah, he did. Okay. Uh, Vigneshwar and Vishwa. Okay, cool. You guys are free to leave. I'll send the recording shortly. But yeah, that's it for today's session. Thank you.